This is a single pole. This is a single throw. This is a single pole double throw.
Yes.
This is a double pole single throw. This is a double pole double throw. Relays are an essential part of the electronics world. You really can't do a whole lot in controls without them. So let's talk about how many kinds of relays there are. There are many kinds. This is one. This is a triple pole double throw relay, and it has a coil of 24 volts DC. So you can take a small 24 volt DC signal and control three different things. There's a normally open contact, and it delivers power when the relay is energized. There's a normally closed contact, and it delivers power when the relay is in the de-energized condition. There are three contacts, three lever arms inside there, and they swing back and forth, and they're controlled by a magnet. The magnet, you can kind of see the white wire and the white portion in there. We'll take one apart and take a look at exactly how they work. But this is just a standard electromechanical relay. There are many other types of relays, which we will try to talk about all of them. This is a time delay relay. It has 11 pins on the bottom of it, and each of those pins plugs into a socket, and that way if the relay goes bad you can just unplug it and put a new one in. But this particular one is from 0 to looks like 10 seconds, so you can get up to a 10-second time delay with this particular relay. There are also relays like this. They go on a terminal strip. This particular one is an Allen Bradley, and it's just like a terminal block when you put it on in the system. And it has a single pole double throw relay in it. Alright. Then there are specialty relays like this one. It is also an 11 pin, and it is used for liquid control, so it's very, very specialized for liquids. there are emergency stop relays. This relay is required by OSHA, the Occupational Safety and Health Act, which is controlled by the NFPA, the National Fire Protection Agency. And this is required by law in most industrial equipment. All right, now we also have, this is a very small relay. This is a single pole, single throw relay. We have relay banks. We have all kinds of relays. We will go into lots of them. Maybe not all, because there are so many it would take, I don't know, a lot of time to cover them all. Here's our relay. Let's pull this cover off. Okay, we got the cover off now. You can see a little clearer. You can clearly see that there's a coil right here. And you can also see that clearly that there are two poles here. One here and one here. If you look really closely, you can see the contacts here and here. Now if I push this, you might be able to see those contacts move. See? That's the normally closed out here. That's the normally open in here. So if I push it, that closes the normally open and opens the normally closed. And if, I don't know if you can see inside of there that well or not, but that's the magnet in the center of the coil. And if you look, there's a little piece of steel in there. So that piece of steel is what makes it move in and out. I hope you can see this well. See that contact coming back and forth? Well, that's how relays work. And this particular one is a double pole, double throw. It has two poles, 1, 2. It's double throw because we have two sets of contacts on each one. We have a normally closed and we have a normally open. So we deliver 24 volts power to this coil, and it controls whatever happens to be coming into, I think we can see the pin. This wire goes down to one of these pins, and it's where the power comes into this pivot bar, and it delivers power to the normally closed contact when the relay is de-energized. It delivers it to the normally open contact when the relay is energized. So basically that's how a relay works. Not a whole lot to it. It's and I advise you, if you did not watch the magnet video, you should go back and watch the video on the magnet so you understand a little bit more about how electromagnets work. And that's what this is. This is an electromagnet. It has no magnetism on it until you apply power to the coil. The coil is nothing but a wrap of wire, and coils are called inductors. So this is an inductive type load. Both of these relays are single pole, double throw. If you look though, this particular brand is Automation Direct, and they have a very reliable relay. I've used them for years. And if you see the little green block on there, that tells you that this is a DC relay. This particular one is a 24 volt DC relay. If you look at this one, you will see the red block on it. The red means that it is a 120 volt AC in this particular case, but they denote these things quite well. So the green is for DC, the red is for AC. It is both of these are single pole, double throw. This terminal is for the common that comes in, that goes to the pivot arm. Then you have a normally closed and a normally open contact. And then these two terminals are for the coil. And you can't see them probably. It's really hard to see because it's just a raised portion on the contact block. But there's a diagram on here that shows you how these are wired by numbers. You can probably see the 13 there and probably see the 1 up there. But if you take this, and this is actually what it is. So the coil is 13 and 14. The common, which is the one that goes to the top of the pivot arm, is the common. Then 1 is normally closed and 5 is normally open. Now they are numbered. They are numbered on this socket. Let's take it loose. You can see these pins fit into this socket. And the numbers are right beside each of the contacts. So 13, 14, this is 9, this is 1, and this is 5. So it's fairly easy to wire them up once you know how everything works. Alright, let's take a look at a different one. This one is a 3-pole double throw. And again, it's a little easier to see the numbers on this one. You've got 13 and 14. We know that's the coil. And if you look on here, there is a diagram. And that diagram tells you, oh boy, the focus is terrible. Okay, that diagram should tell you the numbers of each of the contacts and the coil. So if you look at this diagram and then use the numbers that are on the block, it's fairly easy to do. Again, this would be the common. This would be the ones, these are the wires that go to the pivot arms. And the bottom row is typically the normally open contacts. The top row is typically the normally closed. Not in every case. However, it is a rule of thumb. The red means it has an AC coil, and it will give you the coil voltage on the information here. There's information all over this thing. Matter of fact, you might, I don't know if you can see that or not, but the diagram on the relay, here's the coil voltage up here. It happens to be 120 volts AC. See where it says coil, and that's the part number for the coil. Again, it's an Automation Direct. And let's pull this out so you can see what the socket looks like. It's kind of tight, but these have the blades, not the pins, so the blades plug into here, just like so. Alright, this one is a double pole double throw, and again, here's the diagram on this side. It's a different style. Again, 13 and 14 are going to be, well, actually in this case 13 and 14 are down here. These are going to be the commons. These are going to be normally open, these are going to be normally closed. And let's let you see how that plugs in. See, again, it's blades, not pins. So plug that back in. But it's essentially the same thing for all of them. There's a diagram on the side that gives you the numbers. The numbers are on here. I think you can maybe see something here. I think there's a 1 there. sure there's a 13 and 14 here because typically that's the coil on these blade type ones. Okay, now this relay is an alternating relay, which is a different type that we did not talk about, but it alternates back and forth. You give it a signal and it goes to one position, then you have to give it a different signal to make it go to another position, which we'll talk about all these different types later. But as you can see, it's 24 volts input on the coil. This is a Macromatic name brand. The contact ratings, which tells you how much you can put on the contacts, looks like you can go up to 240 volts AC, 10 amps at 30 volts DC, 10 amps at 240 volts DC, and 1/2 horsepower at 240 volts. This one at the top, it says alternate, lock A, lock B. We'll talk about all that when we talk about alternating relays. But this is also kind of hard to unplug. Let me unplug it. This one has 8 pins. It's called an octal socket, and this one is a pin type relay. Here's the base for it, the relay base. So let's plug that back in. And this is 8 pin, and here's that timing relay again, the time delay relay, and there are all kinds of things on here that will help you. Here's the pin layout for it. Tells you what pin does what, and it is an 11 pin, as you can clearly see. Let's see what that looks like. So this is what the socket for an 11 pin looks like. It has a lot of stuff going on it. But that's there's a pin type and the blade type. There's AC, there's DC, there's many types of relays. But the wiring of them is fairly easy once you get the numbering system down. So if you look, there is a little protrusion on the center pin. Let's take a look at that. If you look, there's a protrusion on that center pin right there. And it starts this way. This will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And on the 11 pin ones, 2 and 10 are the coil. So it'll be 2 and 10. For the coil on this one, but you always have to look for that protrusion that's right there. And you can also see the protrusion in the socket, so you don't put it in incorrectly. It'll only go in one way. And that protrusion is called a key. So these are keyed relay, keyed sockets.